In rotational mechanics, we need to calculate three important things: linear velocity, angular velocity, and angular acceleration. Linear velocity denoted by v, angular velocity denoted by omega, and angular acceleration denoted by alpha. These are the very popular symbols. Some books, some universities may be using different symbols, but most of them are using these three symbols for linear velocity v, for angular velocity omega, and for angular acceleration alpha. Linear velocity is given by formula v equals to r omega, and angular velocity omega equals to 2 pi n, where n is equals to frequency of rotation, and alpha equals to angular acceleration. It is difference of angular velocity divided by time, omega 2 minus omega 1 divided by t. So by using these formulae, we can find out linear velocity, angular velocity, and angular acceleration. Now, by taking one example, I will explain you how to calculate all these three parameters. So here is the question: a wheel of 0.25 meters rotating with 600 rpm, find its linear velocity and angular velocity. And second one, if its speed changed from 600 rpm to 720 rpm in 20 seconds, find its angular acceleration. Here, first we need to find out angular velocity, because to find out linear velocity we need r omega, the linear velocity given by the formula r omega, radius and angular velocity. Without that we cannot find out the linear velocity. As well as to find out angular acceleration, we need omega value, omega 2 minus omega 1 upon t, time. That time is 20 seconds is given in this question. So very important that angular velocity relates to physical quantities. One is the linear velocity and another is the angular acceleration. So whenever such questions are given, try to find out angular velocity as a step number one. In this example, the starting speed of the wheel is 600 rpm and final speed of the wheel is 720 rpm. So let us first find out n1, that is the starting speed. n1 is given by 600 divided by 60, that is equals to 10 hertz. And for the speed 2, that is the frequency, we need to find frequency, that is n2. n1 and n2 are the frequency of rotation. So frequency is obtained by rpm divided by 60. So this becomes 12 hertz. So the speed of the wheel is changing from 10 hertz to 12 hertz. And we know that the omega equals to 2 pi n. So omega 1 is a 2 pi n1 and omega 2 equals to 2 pi n2. So the starting angular velocity of the wheel is 20 pi radians per second. That is, the radian per second is the unit of angular velocity, and final angular velocity 24 pi radian per second. So we got two angular velocities. That is, the angular velocity of the wheel is changing from 20 pi radian per second to 24 pi radian per second. So there is a change in the velocity of the wheel. So when there is a change in the velocity, there must be some acceleration. In this question, the radius of the wheel is not changing. Only the angular velocity is changing, omega 1 to omega 2. So, and so we can find out linear velocity for omega 1 and linear velocity for omega 2. For omega 1, linear velocity v1, and for omega 2, linear velocity is v2. v1 is given by r omega 1 and v2 is given by r omega 2. That is, r is nothing but 0.25 meter and omega 1 nothing but 20 pi radian per second. And v2 is nothing but r is remaining same, 0.25 meters, and omega 2, that is the 24 pi. So multiplying them, we get 15.7 meter per second, that is v1 equals to, and final linear velocity v2 equals to 18.84 meter per second. Now we need to find out angular acceleration. Angular acceleration nothing but given by alpha equals to omega 2 minus omega 1 divided by time taken to change the angular velocity. That is, omega 2 minus omega 1 divided by t. So alpha omega 2 nothing but that is 24 pi, that is the final angular velocity, minus omega 1 that is starting angular velocity 20 pi, and time taken to change this velocity is 20 seconds, already mentioned in the question. So this is equals to pi 24 minus 20 divided by 20, that is equals to pi into 4 divided by 20, 4 ones are 5 are. So alpha equals to pi divided by 5 radian per second square. This is equals to 0.628 radian per second square. In this way, in rotational dynamics, we can easily calculate linear velocity, angular velocity, and angular acceleration.